Compilation is, conceptually, a simple process. We start out with two things and the compiler fills in the rest. 1. The first thing is a generalized machine consisting of ad hoc electronics that presents a simple-to-use API, called opcodes. An opcode represents a block of operations that the machine can perform when given a specific code. 2. The second thing is a blob of bits. The bits represent opcodes. When stepped through in sequence, opcodes cause the generalized machine to perform tasks that we, humans, find useful. A compiler is simply an application that maps a blueprint into a blob of bits that can be executed by the generalized machine. A compiler is an application that is used by software developers to create software products that can be used by end users, who are, generally, not programmers and want the generalized machine to help them perform tasks that they find useful and too boring to do themselves, like calculating their taxes and filling out their tax forms. Developers themselves find the task of building compilers to be boring and dauntingly large and repetitive. They leave the task of building compilers to a select few developers. These kinds of developers are called systems programmers. Can AI be used to build compilers or parts of compilers? Can AI automate the rote work of developers writing applications for developers? Currently, we use blueprints that are but cave paintings of fixed-shape glyphs, characters on grids using programming editors. There is nothing, other than rote work, standing in the way of using more elaborate kinds of blueprints, say drawings of rectangles, ellipses, arrows, and text. There is nothing to say that the figures used in such blueprints need to be arranged on grids. The figures could overlap and be resizable. In fact, SVG already suggests such an arrangement of figures. SVG, though, has mostly been used to create elaborate artistic drawings instead of forming the basis of programming languages. We already know how to build compilers in several stages, e.g. 1. Scanner, 2. Parser, 3. Semantic information gathering, 4. Semantic checking, 5. Allocation, 6. Coding. Can we teach these kinds of divide and conquer task breakdowns to AI? Do we need to come up with a plethora of training examples for each stage? Or can we speed up the training by telling our AI tools to layer their work in certain ways? Thought. Use AI to do the rote, repetitive work, while we, creative humans, give suggestions to the AI tools on how to approach the problems. Maybe AI could perform the task of scanning. Maybe AI could perform the task of parsing, and so on. Maybe AI could be used to scan and parse diagrams.